It's time to get into a little trigonometry. Okay, we're only spend one section on this. You'll spend a lot more time in geometry next year, and then as you get into high school, there's actually some trig classes, or when you get into pre-calculus, you'll be talking about trigonometry. But we're just going to deal with our very basic trigonometric ratios, which we'll talk about in a sec. So trigonometry is the study of triangle measurements, hence the prefix tri. Trigonometric ratios, okay, it's the ratio of the lengths of two sides of a right triangle. So we have three different trigonometric ratios. There is sine, there is cosine, and there is tangent. And we use each one depending on what we're given in our triangle. And you'll see that in a sec here. But there's three trig ratios, sine, cosine, and tangent. And you'll find them all on your calculator. They're abbreviated. Sine on your calculator is SIN. Cosine on your calculator is COS. And tangent on your calculator is TAN. So you have to have a calculator for this part of it. This isn't something that you can just do on paper. Okay, you need your calculator when we do this stuff. So our three trig ratios, sine, cosine, and tangent. If we look back at the definition, it says the ratio of the lengths of two sides of a right triangle. So first thing, I need a right triangle, which I got one here. And we're dealing with two sides. Well, sine of theta, we call this little thing here theta. It's just sine of the angle measure. Okay, I don't know if I'm talking about angle A or angle B in this case in this triangle. So I don't know if I'm talking about this one or this one yet, depending on what we're looking at. So I just call it theta for now. It's just the angle measure. Sine of the angle measure, sine of theta, is opposite over hypotenuse. So basically, if I'm looking at angle B, and I wanted to find the sine of angle B, I would look at the opposite side, which is B, over the hypotenuse. Well, hypotenuse is always opposite the right angle. So the trig ratio for sine of angle B is the opposite side, which is B, small case b, and the hypotenuse side, which is small case c. Okay? So sine is opposite over adjacent. Cosine of the angle is adjacent over hypotenuse. And finally, tangent of the angle would be opposite over adjacent. I'm sure some of you are kind of confused right now. Let's go take a look at this. Let's go see how this works. Let's throw in some numbers here. It says find the values of the three trigonometric ratios for angle L. So I'm just looking at angle L right here. Okay? So if I want to find the sine of angle L, well, let's go back. Sine is opposite over hypotenuse. Opposite over hypotenuse. So the side that's opposite, which is 12, over the hypotenuse, which is 37. And I can just leave it just like that. I can leave it as a fraction. If I want to divide and make it a decimal, that's fine, but let's just leave it as a fraction. Okay, so I found the sine of L. Let's find the cosine of L now. Well, if I go back, cosine is adjacent over hypotenuse. So I look at my angle, I'm using angle L. Adjacent is right next to it, so that's 35. Adjacent over hypotenuse. Well, hypotenuse is 37 still. So adjacent over hypotenuse. And my last trig ratio is tangent. So let's find the tangent of angle L. So here's angle L again. And if I go back, tangent is opposite over adjacent. Opposite, so 12 is opposite. And adjacent to angle L is 35. So 12 over 35. And if I could simplify those, I'd simplify them. But there's my three trig ratios for angle L. Okay? Well, you might be thinking, how am I going to remember that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse? Well, we got a little acronym for it. And we call it SOHCAHTOA. SOHCAHTOA. You're going to hear this a lot. Okay? When you get into high school, I bet your math teachers in there are going to use this too. SOHCAHTOA. Well, think about what sine stands for. Well, S is for sine, right? So O is for opposite, H is for hypotenuse. So, right? Sine equals opposite over hypotenuse, right? SOH. Co, right? Cosine for C equals adjacent for A and hypotenuse for H. SOCA, and finally TOA. T for tangent equals O for opposite and A for adjacent. So there you go, SOHCAHTOA. If you can remember SOHCAHTOA, then you'll always remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? Well, let's figure out what these actually do on the calculator. Okay? They actually give us a ratio. So if I wanted to find the tangent of 52 degrees, I actually want to find it. The tangent of 52 degrees to the nearest 10,000th. I just type it in on a calculator. I go to my tan button, I hit tan, okay, and it's going to pop up tan with a parenthesis, right? And then you want to type in 52. Well, 52. And you don't need to end your parenthesis, but you should get used to it. End your parenthesis, and then hit your equal sign, and it should give you a decimal. The key is you want to make sure on your calculator in the bottom right corner of the screen that it says DEG for degrees. If it doesn't say degrees, raise your hand and I'll come around and help you get your calculator in degrees. There's also radians, but we're dealing with degrees, right? Because 52 degrees. And you'll learn about radians in Algebra 2, so don't worry about it right now. So you just type in tan 52, enter, or equals. And what should pop up is a long decimal. 1.2799416, la da 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 da. And it says nearest 10,000th. Well, let's see. 10th, 100th, 1000th, 10,000th. So let's round. 1.279, and I round down. So there we go. Just type it in your calculator. That's all you need to do. Nothing else. And round to the nearest 10,000. Now let's actually use this to solve for a side in our right triangle. Okay, normally when I have a right triangle, I'm given two sides, and I use the Pythagorean theorem. But here, I don't know what C or A is. But I know what one of the angle measures is. I know angle B is 62 degrees. So I can find what each of these are. First, let's deal with side A. Let's find side A. Okay, so you got to look at your angle measure to figure out which trig ratio you want to use. So here's the angle I'm using. Well, I know the side that's opposite the angle. Okay, and I also know the side that I'm trying to find is adjacent to that angle. So which one deals with opposite and adjacent? Well, think of your SOHCAHTOA, opposite and adjacent. That's right, it's our tangent, right? Tangent of angle B is going to be opposite over adjacent. Because those are the two things I'm dealing with. Now let's plug in our information. So tangent of 62 degrees, I'll put it in parentheses because that's what it's like in our calculator, equals opposite, so 14, over A, because that's what we're trying to find is A. Well, we got to solve for A now, so we got to apply some algebra. I got to get this A out of the denominator, okay? Usually I try to get A by itself, but I got to get it out of the denominator first. So to get it out of the denominator, I got to multiply by A, because that's going to cancel it here, right? It's really like A over 1 and it cancels. So I'm going to multiply by A. Whatever I do to one side, I got to do to the other. So I'm going to multiply by A over here. So my A's cancel. I'll rewrite this. A tangent is 62. A times tangent is 62. Equals 14. And to get A by itself, well, I'm taking A times something. So divide by that something to get A by itself. So 14 divided by tangent of 62. Because this cancels, right? So A is going to equal, I typed that in the calculator, 14 divided by tan 62, end your parenthesis, and you get 7 point, it says around the nearest tenth, so 7.4. So I know that A is 7.4. So you have to use a little algebra there after you get it set up. Well, let's go ahead and let's solve for C as well. Well, a couple ways to do this. You know that A is 7.4. So now you could use a Pythagorean theorem if you want to. But let's go ahead and use a trig ratio just to get used to it. So I'm still dealing with angle 62 here. The 62 degrees. Well, I'm trying to find C now. Well, I know the opposite. And I'm trying to find the hypotenuse. So which one is opposite and hypotenuse? That's our sine, right? So sine of angle B is going to be opposite over hypotenuse. So let's plug in our information. Sine of 62 degrees equals 14 over C. So it's the same thing. I got to do that same algebraic method. Multiply by C on both sides and then divide. What really happened, if I take a look here, was in my old problem, the A and the tangent of 62 switched spots. Didn't they, right? Because A, if I look down here, A equals 14 divided by tangent of 62. That's my quick trick. Instead of going through all the algebra, I just switch their spots, just because I know how that works now. But if you can't remember that trick, go through your algebra. Multiply by C on both sides. And so I'm going to go 14 divided by sine of 62. And we get 15.9 after I round up. So there we go. We solve for the two sides. And if I wanted to find the third angle measure, that's pretty easy because the triangle adds up to 180. So I know that this is 28 degrees. So there you go. You just got to look at the angle you're using, figure out which trig ratio you want to use, and then go through your algebra and solve. We could also find angle measures given sides. But now we have to use our inverse trig ratios, So this is going to look kind of confusing. But let's say I have an angle A. I'm just calling it A. And I'm saying the sine of that angle equals some number x. Okay, if I want to find that angle A, all I have to do is take the inverse sine, and I just switch spots with the x and whatever that angle measure is. Okay, a little confusing, but you'll see it here in the example how easy this can be. Same thing with cosine. If I want to find the cosine of an angle, I just take the inverse cosine, and I switch spots with the angle and what that ratio was. Same thing with tangent. Let's look at an example. This will make a lot more sense. It says find measure P to the nearest degree. So I want to find what this angle measure is, P. Well, let's figure out what we know first. I know the side that's adjacent, and I know the hypotenuse. So adjacent and hypotenuse, that would be our ka, right? So I'm saying cosine. Well, I don't know what the angle measure is, so I'm just going to call it angle P, right? Cosine of P equals adjacent, which is 13, over hypotenuse, which is 19. Okay? And in order to find the angle, in order to be able to switch these spots, I just take the inverse cosine. So when I take the inverse cosine, that's with this little negative 1, these two guys switch spots. So 13 over 19 equals angle P now. Well, how the heck do you do an inverse cosine? If you look carefully on your calculator, here's your cosine button. It says cosine. And in blue right above it, it says inverse cosine. So what you're going to need to do is you're going to have to go hit your second button first before you hit the cosine button to give yourself an inverse cosine. And then you're just going to type this in. So you hit the second cosine button to give yourself cosine -1 with the left parenthesis, and you type in 13 over 19. And end your parenthesis. And you hit equals, and you end up with 46.8 in degrees because it is an angle measure. So if you want to find an angle, it's just the inverse of whatever trig ratio you use. In this case, it was cosine because I knew the adjacent and the hypotenuse for the ka. Okay, I'm sure there's going to be some questions, but hopefully you got a little bit better understanding. And once you get going through some examples, I bet you're going to get this faster than you think. Deuces.